Good morning, students. Nice to have you in class today. I'm still on circle geometry. We want to look at secants and tangents. By the end of the lesson, you should be able to differentiate between secant and tangent, apply the tangent property and its theorem, and also to use the theorem of tangents from an external point. Now, for secant, a secant is a straight line which cuts a circle at two distinct points on the circumference. It's just like now having this as a circle, center O. Now, just like the case that we have a chord, I will say a chord is 2 points on the circumference. Now, when you extend the chord out like this, let's say this is A, and let's call this place B. Now, extending your chord gives you what we call a secant. So, an elongated chord on both sides gives what? A secant. Now, for tangents, a tangent is a line which touches the circumference of a circle at one point. Now, for tangents, when you move this secant downward a bit, when you move it touching the circle, now this is A and B. Now, when you move this downwards towards the circle, at the point where it is touching the circle, now this line AB now, this line AB touching the circle is what we call the tangent to the circle. Now, under tangent to the circle, you need to know this. An angle between a tangent and the radius. Now, if this is the radius R. The angle between the radius and the tangent is a right angle or 90 degrees. Please take note of that because we are going to be using it. Then also for theorem 8, so the straight line which is drawn at right angle to the radius of a circle at its point of contact is a tangent to the circle. This is tangent to the circle. Now we have this. This straight line is what we call tangent to the circle. Tangent to the circle. And don't forget that the radius and the tangent forms what? 90 degrees. Please take note of that. Now, theorem 9. If two tangents are drawn from an external point, now let's call this the external point P. When we draw a tangent from this point, draw another tangent from this point. Now, these two tangents from the external points. Now, take note of the following. The tangents are equal in length. That is, this tangent and this tangent are equal. Then the tangents subtend the same angles at the center of the circle. Now, we can just join this. This is 90 degrees here, and this is 90 degrees. Now, the angle here is the same thing as the angle here. That's what the theorem is saying. Now, the angle between the tangent is bisected by the line joining the center to that is this line here, bisects the angle here, and also bisects this to form equal angles. So, if this is X, this is X. If this is Y, this is Y, and this is 90. So you find out that these two tangents from an external point forms two right angle triangles that are what? That are congruent. So these two triangles are what? Are equal. So that's what the theorem is saying. So, in the course of the Google Classroom, we are going to take more examples to show these theorems and to apply these theorems. Have a wonderful day as we see you next class.